A common way to visualize the magnetic force lines is to take a bar magnet, for example, with the north and south ends, and lay it between a couple of books, and then we can take a sheet of cardboard and place that over top, and then some white paper. And then we can take iron filings. I've got a bottle of iron filings here, and we can sprinkle that over the paper, and then just tap the paper to get the iron filings to line up. And we'll just put a few more at this end here. And then as we tap it, the iron filings line up, and you can begin to see the pattern. So we see at the two poles, the south pole and north pole, we see the lines coming out from either direction and going around. And so the magnetic field gets weaker out here, but it's still present. It's strongest at the two ends of the bar magnet, as we see with the distribution of the iron filings. Now, one nice thing about putting it on paper is that you can take it and just put it back into the bottle very easily. I've placed two bar magnets close to each other with the poles, opposite poles adjacent, so south, north over here. Again, we'll place our cardboard over the magnets and our sheet of paper and sprinkle the iron filings on the paper. And then again, we tap the paper to align the iron filings with the magnetic field. You can see the lines of force attracting each other at the ends. So this is the north and south pole. So we have the attractive forces there, we have the attractive forces at the other end, as well as the lines of force between the bar magnets themselves. If you want to make a permanent display of this, you can take some hairspray and just spray the filings, and they will stick then to the paper, and you can make some interesting artwork with that. Next, we'll take the two bar magnets and place them so that the north poles are on the same side and the south poles are beside each other as well. Again, we'll place the cardboard and paper over top of this and sprinkle iron filings over the magnets. And then we'll again tap the paper. So in this case, we see the lines of force repelling each other. So rather than attracting, they are now repelling. And again, we see the lines of force going this way, but they are now not going towards each other, but away from each other at either end. And because the lines of force repel, it's because of that that the two magnets also repel each other when the poles are similar. Let's see now what happens with a small U or horseshoe magnet. Again, we'll place the paper over top and sprinkle the iron filings here. This is a fairly strong magnet. You can see the lines of force extending quite a ways out around the U magnet, and very strong lines of force between the two ends, the two poles of the magnet. How will a keeper on the horseshoe magnet affect the lines of force? Well, let's look at that again. So now we've got a keeper on there. Oops, let's spread it out a little bit. And again, tap that. And you can see that the lines of force are actually much weaker in this case. Let me just spread it around once again. The lines of force are still here, but not nearly as strong as without the keeper. And that's because the iron keeper allows the lines of force to go between it rather than through the air. And as a consequence, the attraction to the filings here is much weaker than without the keeper in place. Now, what happens if we use a ceramic magnet? I have here a ceramic magnet made with a hole in the center, and we'll place that then under the paper as we did before and sprinkle our iron filings over the magnet. And let's even the density out a little bit. And now we'll tap the paper again. And you can see that the lines of force go out from the top. And actually with a ceramic magnet, it's the surface that is the pole. So this end could be a north pole, for example, and the bottom surface would be the south pole. And so the lines of force actually go out and around. And if we sprinkle extra on one side, you can actually see the filings sort of going up in a three-dimensional arrangement. They're actually going up a little bit and extending around then to the bottom if the paper were free to allow the filings to go through. So this is an example of a ceramic magnet. I'll now take the ceramic magnet and set it vertical and then adjust the height of my books so that the cardboard is just above the surface of the magnet. And then again we'll sprinkle some iron filings on here. And you can see here, this is the orientation of the magnet. And we have then the magnetic fields around the edge of the disc. So very intently around the edges and then going out in all dimensions, as we see here. So how do you clean up all the filings afterwards? Well, just take a strong magnet and hold that over the area where the filings may have dropped, and you then collect them and can then put them back in the bottle.